In this episode of Tech Talk, we're going to look at a Sony Betamax and tear down the front loading mechanism. Now, this is used on the 711B chassis. So basically all the slim line front loaders, with the exception of the SL2000, SL2500, and SL2700. All of the SLHFR30, the 50, the SLHFR70, the SLHF900, SLHF700, 600, SLHF1000, all of those units used the same type of mechanism that we're going to tear down in this video. I hope you enjoy it. So in this video, I'm going to take a look at the front loading mechanism of this 711 chassis. This is called the 711B chassis, I think. Yeah. This was the 711B chassis that Sony had for the Betamax for many years. And I can't actually operate this machine because you see my little note here that says the STK5441 was robbed for my SLHF1000. So this is actually a machine that I used for parts, because I think this might be the machine that I robbed the head or the lower drum or one of the pieces out to fix another one. Anyway, it's a parts machine. And but the mechanism is intact, so I can run this through manually to show you how it works. And that's the purpose of this. This is going to be just to show you the operation of how this thing loads and how it unloads, and we'll do it by hand, how the mechanism works on this unit, so you can get a good understanding of how the mechanical operation of this machine works. So when it's working, this is what happens. When you first put the tape in and the tape goes in, there's a switch that activates. Gotta release the little catch here, wherever the heck it is, right here. Okay, when you put a tape in, the tape releases that catch, which allows the basket to push in. When the basket pushes in, there's a small switch. I'll show you where it is. The leaf switch is right here on this side of the mechanism. So when you push the mechanism in, it closes that switch, which starts the operation of the loading procedure on this, which I'll show you in slow motion, done by hand. So the operation that happens when the tape goes in, it activates that switch. That pulls in the solenoid, the plunger down here. That goes in like that. Now what that does, actually, does it do that first? Yeah, it does that first. It pulls in the plunger like that. What that does, and then the motor that's underneath here starts to rotate. And what that does when the plunger is pulled in is it transfers power through the planetary gear set. This cog here, when the plunger goes in, you see, the cog locks this lever, normally this lever, which is controlled by the plunger, which also doubles to operate the pinch roller. So that's what engages and disengages the pinch roller. When the pinch roller is in place, this lever here, the pinch roller sits up here, this lever here is what engages and disengages the pinch roller, and it also turns on and off the back tension brake over here. You see, there's another lever underneath here that moves. Anyway, when that's in, the motor is underneath here. It's a planetary gear set, and we're going to take this apart so you can see it, but there's a planetary gear set inside this gear. So when the top gear here is locked, through the planet carrier, it'll transfer power to this secondary gear, which is what operates the loading mechanism. You can see it underneath here. Right now it's in the unloaded position. To load the cassette, the plunger pulls in, and now when the motor rotates, it pulls the cassette basket in by means of this tooth belt. So you can see the tooth belt is turning here. It's turning this gear, which is operating the front loading mechanism and pulling the mechanism down in place. Once the mechanism drops into place, there's a switch that gets activated. There's actually two switches that get activated. Well, there's one switch that gets activated. There's two switches, but one gets activated. The second switch is for the record lockout. So if the tab is present on the cassette, that second switch will also get depressed. These switches are right down here. You can see them on the chassis. One of these switches is to tell the machine that the cassette is actually dropped, and the second switch the one on the end here, this is the one that tells it if the tab is in place so you can record or not. But this switch over here a bit, it always gets depressed when a cassette presses it down. That's detected by the physical cassette dropping. As soon as that happens, the pinch control solenoid releases. The motor continues to turn. So that causes this gear to turn in this direction. And now you see what happens. The same motor is running. Now you see what happens. It starts to pull the tape out, both directions, threading the tape, and these folding guideposts here will actually spring up. And once it reaches the end of its travel, there's another micro switch that gets activated. I'm trying to remember where the heck it is. It's in the back of the chassis down here. Anyway, there is another micro switch that gets activated to tell the unit that it has now completed the loading cycle, and then it shuts off power to the loading motor. The tape now stays loaded through all operations. Rewind and fast forward is done by just turning on the real drive motor to which direction it's going to go, and it does have a separate real drive motor for these. You have a loading motor that threads the tape and operates the front loading mechanism. You have a drum motor that operates the drum, and you have a capstan motor that operates the capstan, and a reel motor that operates through this pendulum arm to switch power from either the take up to the supply reel, depending on the direction it's turning. And the pinch roller is engaged again to go into play. That solenoid pulls in, and that engages the pinch roller. When you eject the tape, the motor comes on in the reverse direction. Also, the real drive motor will go into the reverse direction to wind the tape back in as it's unwinding. Now what you'll see happen as I reach the end of loading, you're going to see this little, down here, there's a little coil here. This is what's used to detect the tape when the tape gets to the end, when you're rewinding. It detects the metal leaders. There's one on this side, and there's one over on this side. Just a coil of wire with a ferrite core that detects the presence of the metal leader, because Beta used a metal leader to determine when the tape is at the end, unlike VHS, which used a photo-optical system. But you'll see on this side, as the tape path finishes its unloading cycle, you will see this move. Watch. It'll turn. See it move there? You can see the pink wires. That is controlled by a little cog on the metal gear here from the pinch roller. What that does is, as that turns, it pulls the coil closer to this metal bracket, which allows the circuit to detect the ferrous metal, just like it does when it's rewinding and the metal leader from the tape passes it. It changes the inductance, which changes the frequency of the oscillator. The machine now knows we've completed our unloading cycle. So then what happens? It re-energizes the solenoid, which pulls this lever in, and as the motor continues to turn, I'll just cheat by moving the gear this way, move the belt. Keeps going until the cassette is ejected. Real simple, right? Many people have trouble with this. Let's take this basket out and take a look at the actual gears and how to time the gears on this mechanism. To lift out the basket, I'm just going to remove a couple screws here. I should have grabbed a different machine, one that was functional, so that I could show you it working, but for a static display, you know what, this is just fine. It was just the first Beta machine. I went into my storage unit, and it was the first Beta machine that I saw of this chassis. I've got a 712 chassis, which is a completely different animal, and I should show you that one because it's a plungerless system. It's actually it's even simpler than this. It's a plungerless system. So remove the screws. I have to lift this gear off, so the easiest way to do that is just to lift the top of the pulley off. It just clips in place. Now I can lift off the tooth belt, get that out of the way, and the whole front loading mechanism will lift out. I'm just going to release a couple of catches on the front panel here a bit, just so I can get some clearance, and then I can just lift the front loading mechanism out. Come on, come out, there it is. And I'll unplug the wires over here. These are what goes to the switch. Okay, now we've got this out of the way, I can set the rest of the machine to the back of the bench, as we don't need to look at that right now. We're going to concentrate our efforts on the front loading mechanism. So here's the left side of the mechanism, and as you can see, it's just a simple gear, and it meshes with a gear that's connected to a shaft which goes through to the other side. And we're going to take this whole thing apart. So I'm going to take all these gears off. So I'll start by just removing this gear here. I'm just going to remove the little catch, pull the catch down. I can pull the gear out just like that. And I guess to take it off, I'll release the top piece of this too. There's a couple little catches here I just have to release. Grab a small screwdriver for that. That one will do the job. Okay, release this little catch here. And this will pop up. Okay, there's one gear off. We'll do the same on the other side. I'll release this side here as well. Okay, there's that down. Now we'll take apart this piece here. Need a number 1 Phillips. There are 3 screws on the side. I'm just going to remove the rest of this unit, get it out of the way for now. Oops, get hung up on soldering irons and stuff here. I'm going to get this unit out of the way. So that I have a nice clean bench to work on this mechanism. Okay, so what we have here, if I pull the side panel off, as you can see, the whole mechanism is now ready to come apart. I can pull the basket and everything out, but there's the side piece off. And what we've got is we've got 4 gears here. We've got our right side loading arm, this side being our left side loading arm. We have our split gear, and we have our cam gear, and we have our worm gear, and these all can come out. So I can take all these gears out like this. And you're probably wondering, how am I going to get these things back together, because I'm not really paying attention to where they are. Well, it's because there's timing marks for everything. So now I'm down to just the one gear that connects one side to the other. And a real common problem on these, by the way, is take everything apart here. Why not, eh? A real common problem on these units is these gears here in the end. Real common problem. What happens on them is they crack. So now the whole mechanism is taken apart. What quite often happens is this gear, where it goes through this, it's not a round shaft, it's got a flat side on it, so it's a keyed shaft. These gears have a tendency to crack right here, and when that happens, the gear will turn, but the basket will go out of alignment because it'll slip. So that's a common fault on these things. Okay, mechanism's all taken down into pieces. To put this thing back together becomes a bit of a chore. We first have to put in our connecting arm gear. And I'm not even bothering with these other ones right now. We'll just move them out of the way. And then we put the other side in here, into that into that bearing assembly, and we'll reassemble and lock it in place like that. Okay, that holds that portion of the mechanism together. The next thing we need to do is put the cassette arm or back together, cassette mechanism back together, and oh, this is the arm here that lifts up the flap on the tape, by the way, and there's also a little spring over here. There's another little, there's two little levers here that hold the cassette in. They're held in place by a spring. The next thing we'll put in is we'll put the actual mechanism back in, the front loading mechanism. A couple pins here, and they slide into the grooves, just like that. So we can slide those back together just like that. Now, of course, what holds this thing together is the top bracket. So we'll put the top bracket back on and snap that in place. Because without the top bracket in place, it's going to be hard to hold the mechanism together. So the top bracket just slides in like that. Now our front loading mechanism, and I can release it here, it's free to move back and forth and lock into place. We go to our left side arm. We have to get our left side arm in. Left side arm just have to get it in here. It's easier if you move the basket, by the way, to the back. So we take the basket all the way back like that. We can now put our left side arm in place and get it locked into place like that. Get it locked onto the pin. It's got to go over the arm, the pin there. Now it's locked into place. So now our left side arm is in place. We do the same thing for the right side arm. Get the right side arm into place. Now we're not worrying about the timing of it just yet. We're going to get the timing there, but what we want to do is we want to just basically get the right side arm in place as well, just so that it's lining up with the cassette when it's down. So basically you have the cassette all the way down on both sides, and that is going to make you fairly close for your alignment. When I raise this up now, if I turn this gear, the mechanism will lift on both sides. And you want to make sure that it lifts evenly on both sides. When you're back all the way, there will be alignment marks that will line up on both sides. And actually the alignment marks on these are when they're in the down position, there's an alignment mark too. If we're down, you will see that there's a cutaway gear here. So we're on the last tooth right there, and the same as on this side here. We're on the last tooth for down. Can't go any further down than that. So we're all the way down. There's our last tooth, and it's lined up with the midway or the power transfer gear for both sides. And here we are on this side. We're all the way down. So now if we raise this up, we're all the way back and we're aligned up. You can also put on, this is the lever that operates the cassette door to open and close the door. And it sits in place. It fits onto this shaft here, goes onto this post here, and it just rides up like that. Got to lower this down first. It goes in behind this piece. So it's going to move this forward. This goes in behind like that. So it meshes up with this cam. So that when the tape is being ejected, as you'll see, this actually meshes with the little teeth on the door here to open the door up. So if I put this back in now, this is in the down position. So if I slide it in like that, and lock it in the down position. When this lever moves, it'll open the tape. I'm not in the right position. I'm in the wrong position. It's like that. Okay. Now I'm lined up. So now, as the mechanism rotates, it is going to operate, this cam is going to operate this lever, and it's going to open up the cassette flap so that the tape can be ejected. So that's now lined up. Now we have these other two gears. We have a midway gear, which is a split gear, and there's a spring in here. So if you take this apart, be careful. You just rotate it to the right a bit and it'll actually open up. But be careful because there is a spring in there, and if you aren't careful, that spring is going to fly out at 100 miles an hour. Another common point of failure on these is these little tabs can break off on these gears. Very common failure. Spring fits in place just like this. Goes in. On the left here, your upper clip, and on the bottom is on the right, and it goes in place and it locks in behind this little green tab here, right there. Now we take the top part of the spring and we're going to put the top piece on, and we're going to turn it counterclockwise. I think it's counterclockwise, or no, it's clockwise. Where is it? It goes in under like this. It actually goes in under this piece here. There's a two-sided cog here. You put it in like that, and you get it locking up against it. Now I can feel the tension. It's trying to push back, right? And I turn it clockwise until I can line those teeth up. You can see the teeth that I just locked in there. So this tooth is going to go and lock underneath here. So I take this gear and I have to catch it on the catch here on the cog. So I've got it. I can feel the resistance. I just give it a turn. There it is. This is what gives you the resistance when you first push the tape in before the motor starts to kick. This is what allows you to push the tape in enough to activate the switch. Okay. Otherwise, if that wasn't there, you wouldn't have any. You'd be pushing the tape, and the tape would have a lot of resistance. It wouldn't have that nice springy feel to load the tape. Okay, now we need to do the alignment on here. Now, this is where you get critical. When we put this in, there are holes on the chassis. There's a hole right here. You can see it on camera, right where my finger's pointed. There's a hole there, and it lines up with this cutaway portion of this gear. There's a hole here that is going to line up with the hole in this gear when we are correctly aligned. So I pull this back, put a little bit of tension on it to pull it back. I take this other gear and I drop this gear in so that I can see light through below it. So now I can see light, I can see the hole in behind there. I don't know if you guys can see it on camera or not, but there is a hole in behind there and you can see light through it. That's the second gear that goes in place. The third gear, this is a unique gear because of the way that this one is shaped. As you'll see, this is only a half gear. It's got half teeth on one side, and it's got the fine teeth which mesh up with the worm gear that is driven by the belt coming from the loading motor. So it goes in like this. Again, there's a hole on here that lines up with that hole on the chassis. Just line it up, drop it in. Couldn't be simpler. Okay, real simple mechanism. Okay, now the worm gear. The worm gear just sits in place like that. And that's all there is to it. It just sits there because what holds it in place is this bracket. So that mechanism is back together. A big common problem on these is this bloody switch. These switches go bad. Now the switch can be removed. You don't have to take this machine apart to get at the switch. There's a little plastic tab here. If you just pull that little tab out of the way with your fingernail, you're actually able to remove the switch so that you can replace the switch, or you can clean the contacts or whatever you want out of the machine. Let's pop this thing back together. So now I've got this in place. I just take my cover and I just drop it over just like that, and I put my 3 screws back in. just like that. And the next thing, I'm going to run a beta tape through this thing as the bare front loading mechanism, not in the machine because the machine won't power up. But I can run a tape through here to show you guys that it is actually timed correctly and the tape will drop down. Okay, the little switch here again, it goes back in just like it came out, and it's actually activated by this cam on this gear. When you push the tape in, you'll see the cam move. See the cam moving here? That's what activates that switch to turn on the front loader. So it's in normally open, and when that cam presses it, it closes that switch. So that just goes back in just like that. Okay, let me find a beta tape. So when you put the tape in, tape goes in like that. You push it, it operates the mechanism, motor turns on, tape drops down, just like that. Tape's now all the way down. When you eject it, motor, after it's finished unloading, motor comes on, raises the tape up, opens the back of the tape cassette, kicks the tape out. That's it. 711 B2 chassis front loader mechanism, how to take it apart, how to put it together, and what the common problems are. Okay, the next thing we're going to look on this chassis is the power split device. It says that it uses a single motor system, and it uses a solenoid and a planetary gear set. So this is the power split device here. We're going to remove this mechanism from the top of the solenoid. There's a couple things that go wrong in this particular mechanism. So I'm removing, I guess I got to take that shield out of there too because it's kind of in the way. I'm going to remove this piece. Get these wires out of the way. Okay, this is the loading motor assembly. It's part of the planetary gear set. It's going to unplug it because Sony was great for putting plugs in. Here's the solenoid I was talking about. Now keep in mind this solenoid does have some issues with it. Sometimes it would get stuck or it would overheat, and there's a little thermal fuse inside underneath one of the on one of the windings here. You can actually open up the blue tape here, and there's a little thermal cutout. So sometimes what would happen on these is they get sticky and they'd overheat and burn out that fuse. So if it doesn't go clunk, 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 and the voltage is there, you can measure the voltage. It's I believe it's these wires here. Pretty sure that's the one. Anyway, you can measure the voltage for the solenoid drive, and if the voltage is there and it's not kicking back and forth, the thermal cutout has probably gone open on it. Quite a common problem. Anyway, let's take a look at the planetary gear set. This is the loading motor planetary gear set. And what this does, I can even put power to this thing so you guys can see it working. Loading motors here, spins into the planetary gear set, and depending on whether this cog is locked or the other one, it's going to transfer power. It's either going to transfer power from the motor to this top gear to open load and unload the tape, or it's going to transfer power to this gear, which is then going to turn this metal gear, which is going to operate the loading ring. Okay, so I've got some power that I can put to this thing, and when I clip on here, I'm just trying to find a good place to clip on. Clip on that one, and the other side to the motor is here. There we go. Okay, so as you can see, when the motor is turning, you can see the lower gear here is spinning. The top gear is locked in place, so the planetary gear set is actually the sun gear is the middle gear, which is what's being turned by the motor. And the top gear, I believe, is turned by this is the ring gear, and the planet carrier is the one in the middle, which is what's turning this gear here. Now when the solenoid kicks in, it locks that one, which locks the planet carrier, and it applies all the power to the top. Very simple. Oh, and by the way, for you guys that are enthusiasts, this is exactly how an automatic transmission in your car works. Similar. They use clutches and brakes to stop them, but this is a planetary gear set, and this is exactly how an automatic transmission works in your car. One gear at one speed, and then one clutch will lock and the other one will unlock. And now you've got a second gear and a third gear and so forth. But there it is. That's the planetary gear set. Let's take this one step further. Let's take this thing apart and just examine what is in here. So I do that by just removing this cut washer that's on the top here, which is easier said than done, but it will come off. Okay, so motor shaft turns, right? And you've got our two planetary gears here that are now freewheeling because, of course, there's nothing to stop them. They ride around the inside of the sun gear. Or sorry, the sun gear is this one. They ride around the inside of the ring gear, which is this one here. If the planet carrier, which is the one in the middle, is stopped, it will force the power by means of the planet gears, which are these little ones here, to make the ring gear spin. If the ring gear were to be stopped and the planet carrier gear released, and they would transfer the power to, so if I were to stop the ring gear from spinning, the power would transfer as the motor spun. It would spin the whole thing like this because the ring gear is now stopped, and it will spin the whole thing as one piece like that as it's turning. We lock this one, and then the planet gears spin, and we'll turn the ring gear on top. It's a pretty simple concept, as I just demonstrated. So, put that back together now. These generally don't give trouble on these machines. I just wanted you to see what was inside that assembly. But they generally don't give that much trouble because they're not being used that much. This comes on, and it spins for, what, about 3 seconds to load the tape and another 5 seconds to thread the tape. And it doesn't come on again until you press the eject button. And then when you press the eject button, it goes in the reverse direction, run for 5 seconds in this mode to unthread, and then another 3 seconds in that mode to kick the tape out. So this particular part of the machine does not get much use. But parts that do tend to break on here, this has got the upgraded metal gear. Some of the earlier machines, this was plastic and the teeth would shear off. So they learned from that. But this part on these machines was actually quite reliable. There wasn't a lot of problems. The biggest problems on the 711 chassis, and not so much these machines, but the SL2000, the SL2500, and the SL2700 suffered from the guide pin failure. They break. I have to put this back in order to show you that portion of the unit, how it moves. The first 711 chassis, this is the 711B, but the first 711 chassis, where they actually had a separate motor to load the tape in, they had a completely different front loading mechanism, which was really problematic. It had a couple of little gears on the front here, and it ran down with gears. It had gears all the way along it. It had a motor on its own, and the loading assembly had its own motor as well. On the 2500 and 2700 series, the 2000 was a top loader as it was a portable, but it used the same mechanism, and they had independent motors. They had a separate motor for the supply and the take-up. But a lot of problems with those. Biggest problem with those was the shearing of the guide pins. The guide pins I'm talking about are the ones that retract. These ones here that you'll see, and I'll get a close-up of it in a minute if I can. Take this top off here so you guys can see it a little easier. So I'm referring to, okay, still can't see it very well. Turn it around there a bit, now you can see it better. What I'm referring to is I'm referring to this block assembly right down here that you can see as it comes out from underneath the mechanism. This block assembly is metal on this one. That's the upgraded design. The original ones, this was molded into this nylon plastic gear. And what would happen on them is it would break. And the guide pins would break off and you'd end up with, and it usually happened, never happened on its own as a rule. Usually it happened when somebody ran one of those all-sop head cleaners, you know, the ones that you put the liquid on. They said, oh, our wet cleaning system is better than the dry cleaning. And Sony was screaming, don't use wet cleaners on VCRs. It's stupid. It's dumb. Don't use them. Use our tape. Our tape is dry. Our tape doesn't damage parts. But of course, the Allsop Corporation, good advertising. It's kind of like Monster Cable, right? It's all this hype over crap. But Allsop was very good at marketing, and they marketed these wet cleaning tapes. And when people put them into a 711 chassis Sony Betamax, didn't cause problems on the old 710, which was like the SL5200. But the 711 chassis, with its fragile guide pins, we ended up with guide pins snapped off, broken left, right, and center. And it was a nightmare. It was a PR nightmare for Sony. They had to come up with kits to fix them. And you would think that we would just change the whole entire loading ring assembly, but no, that's a lot of work. When you've got to start taking this whole mechanism apart to change that, you're talking a good hour, or at least in labor. You've got to remove the drum, and you got to remove everything to change that stupid gear. The whole Betamax is built around that stupid design. So what they came up with was a design where we used little nippers, and we actually nipped off what remained of the little plastic loop that was snapped off of the gear, and they came out with, because there was a couple screws in them already, to hold the spring in place and stuff. It had a little metal plate with the spring attached to it, but the guide post itself was actually attached to the gear, a little pin through it, and that broke. So we had to take little nippers, which are like, they look like little needle nose pliers, but they have a little shear on the end of it, little flat type nippers. We'd actually have to nip out the gear, the remains of the gear that was broken, and then we could put the guide service kit in. So instead of it being an hour to take the mechanism apart to replace it, it was a 10-minute, 15-minute job that we could charge an hour for. And real common problem on that. Nightmare. It was a PR nightmare for Sony. I'm sure that they probably ate a lot of repairs on those because you'd get people that were just absolutely livid that this happened. And this is before the internet. But the word would get out that this was the problem. And there was a lot of finger pointing going on. And Sony would cover it if they couldn't prove that someone used an all-sop cleaner. But if a machine came in, and they quite often did, because once the guide pins broke, the machine shut down and you couldn't get the tape out. So when a machine came into the shop, and it had one of those all-sop cleaners in it, it didn't matter whether the machine was still under warranty or not. They could have bought the machine a week ago. They were getting stuck with a $120 or $140 bill to fix it because the kit itself was quite expensive. Didn't matter. Warranty null and void. You should have seen the sparks fly. When I would phone people and tell them, hey, I got bad news for your machine. What do you mean I got bad news? Well, your Allsop cleaner broke it. I'm going to sue Allsop. I'm going to sue Sony. Yeah, good luck with that. Here's what it's going to cost to fix it. You want it fixed? Okay. I'll have it ready for you in a couple of hours because we used to stock the kits. But very common problem on the 711 chassis. Not this one. This is the 711B chassis. But the SL2500 and SL2700 and the old SL2000s suffered from that problem. Anyway, so that was one of the early slimline chassis, and this was the second generation slimline chassis. And then there was the other one that I've got, and I don't know whether it's the 712 or the 711B Mark II. They have so many different numbers, right, for Sony. Anyway, that's this one. I just wanted you guys to see this. Hope you learned something about this mechanism, and hope you enjoyed this video. Hit the thumbs up key, and you know what? If you like this type of stuff, please consider following me and send me something on Patreon or even through PayPal. I've mentioned it before, but the advertising revenue on YouTube, it's absolutely horrible right now. There's a lot of advertisers running away due to some objectionable content from some other channels, and the advertisers are punishing us all. And between the ad revenue dropping because advertisers are dropping Google, and the fact that many people are still using ad blockers, and I do get stats, so I know the percentage, I know the payout on the ads, and I know the percentage of views versus the percentage of paid views. So, you know, I'm going to leave that one alone because I know there's a few people up there that have really gotten upset with me even suggesting that they watch a single ad. But keep this in mind. I'm giving you guys information. I'm teaching you guys how this stuff works and how to fix it. Invaluable information. I think that my time is probably worth a few cents for an ad that you watch. If you don't agree with that, you can always subscribe to my channel and subscribe through Patreon. If you want to kick a couple dollars my way, it would be greatly appreciated. We'll catch you in the next one. Bye.